Let's do number 10 from section 2.3. And it says, let A and B be n by n matrices. Show that if AB is invertible, so is B. Okay. Now, one of the main ideas in this section is what's called the invertible matrix theorem. And we can abbreviate it IMT, the invertible matrix theorem. So let me make the statement of the theorem first before I use that in the proof here. The invertible matrix theorem says that A is invertible if and only if AX equals 0 has only the trivial solution. So that's kind of the big theorem in the section. All right, so we're trying to show that B is invertible, given the assumption that AB is invertible, okay? So let's try to prove this. Let's try to prove that if AB is invertible, so is B. So let's assume that AB is invertible. We know by the theorem I just quoted the matrix equation of AB times x equals 0 has only the trivial solution. Okay, now I think what I'm going to do in this case is prove this by contradiction. So I'm going to assume, if we assume B is not invertible, then by the inverse matrix theorem, Bx equals 0 has a non-trivial solution. And I'm going to show you that you get a contradiction if you make that assumption. Well, if that's true, if Bx equals 0 has a non-trivial solution, this means that Bx is equal to 0 for some x not equal to 0. And remember, x is a column matrix. It's a vector. It's not a number. So I'm not using boldface notation here, but essentially that says that Bx is equal to 0 for some column vector x not equal to 0. And here's where the contradiction comes in. If we multiply the equation Bx equals 0 on the left by A, we get this. A times bx equals A times 0. And remember, in this case, we're assuming x is not 0, because we're assuming that b is not invertible. So that implies that there exists some x that's not equal to 0 that satisfies that equation. But this equation implies, and I'm allowed to move around those parentheses, by the way. There is a property that says you can move your parentheses if all the products are defined for matrices. Well, notice what that implies. If I move my parentheses around the AB and I use the observation that matrix A times column matrix 0 gives me column matrix 0, I get this equation. So I've just shown that AB times some non-zero column vector is equal to the 0 matrix. And by the invertible matrix theorem, that implies that AB is not invertible. And that is a contradiction. So this is a contradiction. So our assumption that B is not invertible is false. So we conclude that B is invertible. So that's just a nice little proof by contradiction using the invertible matrix theorem.